Hello, so let's talk about model exploration. This is usually done using the neighbor view, which has a set of tools for navigating around the model. So the first one is called, well, the first one is none. That means whenever you hover over something, you just display the properties of this entity. So let's hover over the reaction. As we see here, it has an idea, whatever you find in the SBML file, flux upper lower bounds, equilibrium constants. It has reactants in the list with the corresponding stoichiometries and the products. One can add or remove genes from them, etc. Every species, on the other hand, has an ID, a name, a compartment to which it belongs. In this case, it's cytoplasm. Maybe a boundary condition species. That's common in some models. And finally, it can have a formula or a KEGG ID, if that is applicable. You can also select with your right mouse button. You can also select compartments. They all have an ID, a name, and what is outside. Here you can actually select what should be outside if you are interested in that. Now to deselect something, you right click at some blank space, and twice you select it, it's there. If you don't select anything, you will just keep changing what you're focusing at depending on where you put your mouse. Now let's look at some more exploration tools. The first one is egocentric. It's actually quite simple. It just shows the nearest neighbors of your reactions or species. Now if it's a reaction, obviously all the neighbors are species, so let's look at some reaction here. Something interesting. This is transport reactions. So let's look at this one. And in the hydrogenase, it has one reactant, one product. They are listed here and visualized with the corresponding colors in this graphical interface. So the products are always blue, and reactants, the links to reactants are always red, and you can then kind of go to the reactants and see what reactions produce them, for example, and then you can move around the model in this manner. Now when you click on a species, you see producing reactions, consuming reactions. Here we just have one producing and one consuming. Now if you select something a bit more common like phosphate, we suddenly see a very large list of producing and consuming reactions. And there is also these purple ones called bidirectional reactions, which basically means reactions that can either produce or consume this species. Now let's look at node ancestry mode. What it does is that it shows the imports that are necessary and the pathway that's necessary to produce a certain metabolite in your network. Of course, it should be possible to produce it, and it shouldn't contain any loops. So when there are loops involved of some sort, like a metabolite turning back into itself, then you get, but then it doesn't. It just shows the loop in black, as you see here. Otherwise, it shows the production pathway in purple in an overlay. So let's find some decent production pathway. This one looks relatively simple. We are producing D-ribose 1-phosphate, and let's look at what it actually needs to be produced. It needs the import of uptake of phosphate, it needs the uptake of inosine, and the uptake of H+, which is kind of alright. Of course, this is not the only synthesis pathway that is possible. It's just the shortest one. I mean, if it would show you all the possible pathways, they could be arbitrarily long and complex, which you probably want to avoid. Now on to the next exploration mode, and that is block module. Now you see those red groups of red reactions. As you see here, we have the peroxisome. It's actually fully dead. Now this reaction, the dead reactions in dead species actually appear in groups, which we call blocked modules. In these blocked modules, blocked reactions appear in connected clusters with blocked species, but they're quite difficult to untangle as you see, because they're quite large now, especially within the context of the whole model. So now, instead of looking at them like this, at this model, we can use the view blocked module and visualize the blocked module by itself, which should make it easier to see what the problem with that blocked module actually is. Now you see this one is still quite complex, but it's much more manageable in terms of understanding it than when the whole model was there. Now you can go back using view whole model. A simpler case is this. Looks pretty complex on the lower side of the model. Now if we go into the blocked module view, it actually looks pretty simple. And what we can see here is that the reason why these things are probably blocked, these reactions, is that there is no export of that compound, and it looks like there is no input of that compound. So if one adds them, everything should be fine. Now, the final way of exploring the model is called error tracer. We are going to come back to it later because it's a complex system in itself. What it basically shows you are the sources of inconsistency in any reaction in the model. But we'll talk about this in its own video. So let's go back to this later.